Hi, this is Developmental Assessment Part 2. Let's see, there we go. All right, so I know we just went over this, but let's review that norm reference tests are one in which the child is compared to a large amount of data on normal children that child's same age. So we're making a comparison to normative data. Criterion reference test is one in which the child is compared to themselves. So an example would be the WeFim, where we're actually just assessing at what level is this child at. How well can they dress or bathe or feed? Similar to the FIM. So we only care about the child's performance and are they a description of that performance and are they able to move forward. And there might be a developmental aspect to it. So for example, the WeFim is for children under the age of 8 or up to the age of 8. But you're not comparing their performance to other children. So now we're going to talk about statistics. I know that's everybody's favorite thing. And you should remember the bell curve. And the bell curve basically gives you a normal distribution, saying that if you're looking at the whole population of something, that the average scores should be that 68% of people fall in the middle. 68% of people fall between -1 and +1 standard deviation. So if you get a -2 standard deviations, then you actually represent only 2% of the population. 98% of the population had a better score than you did. If you have a -1, then you represent 15.5% of the population. So you can see why, generally speaking, we feel that if somebody is below -1 standard deviation, they're well outside the norm and they may need occupational therapy services. So standard deviations use measures of central tendency that tells you the middle point for a distribution. And you're probably all familiar with the mean, the median, and the mode. Usually when people say average score, they're talking about the mean, which is where you add the scores all up, and then you divide it by the number of scores that were added to come out with an average score. Median is when you have a whole bunch of scores, and you line them up from low to high, and the median are the ones that are right in the middle. And then the mode is the score that occurs most frequently. So when someone is talking about an average score on something for a particular group or sample, you want to make sure, what kind of a score are they talking about? Mean, median, or mode? Because they are all different and mean different things. So all three of those are used to compute standardized scores and standardized deviations. If you're right in the middle and it's the mode they're talking about, then you've scored the score that is obtained most frequently by the people in the group. So standardized scores and z-scores are pretty much the same, and the central score is 0, and you go up and down. Go up and down the scale. T-scores take those same raw scores and convert them so that middle score, instead of being 0, is 50. So they really mean the same thing. They're just been translated from the middle of 0 to the middle of 50. On the Peabody, the middle score, on the Peabody with the developmental motor quotient scores you get, put the center at 100. So if a child falls between -1 and +1 standard deviations, that means their score landed between 85 and 115. So some other standard scores that are used are percentile ranks and age equivalencies. So percentile ranks can be a little confusing to parents because they associate them with grades. For example, if you told a parent rather, that their child scored in the 50th percentile, in their mind they might be thinking that my child got a D or an F actually. When actually that just means that they're right in the middle, that 50% of other children did better and 50% of other children did worse. So actually being in the 50th percentile is not a problem at all. So that that is something that you need to carefully explain to parents. Age equivalencies, on the other hand, seem to make sense. If I say to a parent, your 3-year-old has the motor skills of a 6-month-old, they're thinking, yeah, I know what a 6-month-old looks like. They can maybe start to crawl, they can maybe sit up independently. However, age equivalencies are not based the same way as other standardized scores, and just a small change in score can make a big change in age equivalency. So statistically, they're really the least accurate kind of score. Plus, if you test a 3-year-old and they score in the 6-month level on gross motor scores, and you test a 6-month-old and they test in the 6-month level, they really don't look the same. The things that the 6-month-old can do and the 3-year-old can do with that same score don't really look the same as each other. So that's important to keep in mind as well. So validity tells us if the test is accurate. Do the scores measure what do the scores measure what they say they're measuring? And is there an actual relationship between the scores and what the test is measuring? So construct validity and content validity, kind of similar and a little hard, I think, to separate out. But basically, does it measure what it says it's measuring theoretically? So, does it measure gross motor skills if that's what it says? And we can look at that by comparing the results of, say, the Peabody to the Miller assessment for preschoolers. Do they come out the same? Do they both say good gross motor skills or bad gross motor skills? Factor analysis is looking at the individual items on a test to see if all the ones that are supposed to measure, let's say, gross motor, come out the same, or all the ones that are supposed to grade visual motor actually come up with the same kind of score for the same child. So those are within the test. Then we can do test retest. So if I give this child this test and a week later I give them the same test, are they going to come up with the same score? You can also have content reviewed by experts. Someone who's done years and years of sensory integration can look at the sensory profile, for example, and say, yes, this does seem to be the right things in auditory domain or in the visual domain based on what they know as experts. Criterion validity tells you how well the scores represent the child's current performance. Concurrent validity, or how well the scores predict future performance, which is predictive validity. So again, a test you may not be familiar with is the Miller assessment for preschoolers, and people have done research to see, can a score on that test predict how well the child does in kindergarten? Can they predict future performance? As well as concurrently, does it actually represent their performance that they're able to do right now? So the Roche analysis is a fancy statistical way of looking at individual items on a test and seeing which ones best measure the outcomes that you're trying to look at. So, for example, the Brunig-Sosaretsky has a long version, but it also has a short version that quite possibly was based on Roche analysis that shows you, okay, if you use this minimal number of items, you will still get a good measure, a good objective measure of performance. And sometimes it's helpful to have a shorter version that you can give if you don't, if you're in a situation where you don't really have time to give a longer version. So reliability can look at precision and consistency over time. Reliable, do I get what I need to get, and does it happen the same over time? Every time the person is tested, do I still get that same score? So inter-rater reliability is reliability between more than one person. if two people are rating a child on the same performance, do they come up with the same scores? And then test, retest, as I mentioned, when you test the child and then you test them again, do you get the same scores? So this has been Statistics Quickly, and now we have 5 questions for you to answer based on these presentations. And I will be I'll be posting the questions on the Blackboard for all 3 classes, and it'll tell you where to download the questions. It'll have the links for the videos, and it'll tell you where to submit them. Hope you guys are all snuggled up warm. Bye.